very much. I want to thank Roland for inviting me here, and it's good to see lots of familiar faces over the years. I was saying to Pat, he's the only person whose textbook I still have on my desk, because every other textbook is pretty much useless, and your textbook that you gave, I actually still use it on a regular basis. So that's a good one that you
Stop asking people to buy it.
So my presentation today, I'm okay with people jumping in throughout it. We don't necessarily have to wait to the end for questions, but I do have a bunch of slides we can get through here. Roland told me 45 minutes, so I will stop right at 45, and then we can answer maybe some questions at the end here. Just a kind of a quick overview. Basically already talked about my background, and then I'm just going to kind of jump into my current job and what it is that I do, and then I have an infinite number of photos that we can go through. So once we hit 45 minutes, we'll pretty much stop there. So as has already been mentioned, I started at Camosun College. I'm from Victoria. I wasn't too sure if I wanted to become an engineer. I didn't really want to do 5 full years of university and then realized I didn't want to do it anymore. So I did 2 years at Camosun. I really liked the materials testing. I liked the surveying. I liked being involved hands-on. So I took a bit of a plunge and I did their bridge program, it's called. So you do a bunch of chemistry and biology and a bunch of advanced math to eventually go to UBC. And then when I came to UBC and I took courses from Carlos Ventura and Pat and other people, and I said, yeah, no, I like this. I can continue on and become a full engineer. So my Bachelor's of Applied Science was from UBC. I graduated in 2010, and as was mentioned, I feel if you're going to tell someone how to swing a hammer, you should probably have swung a hammer a few times in your life. So I got jobs in construction. A lot of my friends were getting co-op jobs working straight to engineering. I said, no, I really want to pour some concrete first. It was tough work. I mean, you're sweaty and it's gross, and it's just, I didn't really want to do that for the rest of my career, but I'm so thankful I actually started doing that, because it really gives you an appreciation of how to actually build things. I remember when I was in my final year of UBC, we were doing a concrete design course with rebar, and of course you have the rectangle, which represents the cross-section, and then you have a couple of dots, which represents the rebar, and somebody put up their hand and they said, how does the rebar just hover in midair? How do you do that? Because none of them had seen rebar chairs, and we never designed, like we never seen and that sort of stuff. So I'm really thankful that we had professors, like sort of pick on you, Pat, but people like that who said, go get an actual job here and you'll see how it actually goes together. So I did some jobs in construction, and then when I eventually got hired by Delcan, and I worked in the highway design division. And then when I came back, I worked for the bridge division. So when I started there, I originally started in Calgary, and I did independent design review of the Calgary Ring Road, the Southeast Stony Trail. And basically my job was on Monday morning, I would get a 90% design package, and I would spend the week putting it into Midas or other 3D software programs. And then by the end of the week, I would try to figure out the various different areas where we needed to add more rebar or change different things. And of course, that goes through a number of levels of iteration with senior people. One of my bosses, Matthias, is here, so that's the sort of thing that he helps us out with. And I did that for about 6 months, and I liked it, but every day felt like the absolute hardest homework assignment ever. And I didn't really want to do that for 40 more years. So I really respect Matthias and how smart guys like he is, but I then got an opportunity to do bridge inspections. So on day 1, I was in Banff National Park. I was hanging underneath a bridge, and like a moose walked underneath me. And then on day 2, I was in Jasper, and on day 3, I was staying at the Chateau Lake Louise. And I thought, you know what, this is a lot of fun, and I really like this, so I'm going to try doing this for the next few years. And I've been doing that for the past 10 years. So I have pretty much, I've seen a lot of different bridges all over North America. I have my PEng in 6 different provinces, because I work in all of those provinces, and I also have my American PE in 3 different states. So I've given this presentation a few times. The Canadians always come up to me afterwards and they say, how do we get the PE? And the Americans always ask me, how do we get the PEng? So if anyone here wants to get the PE, don't ask me now, but afterwards I can tell you the various different steps. It is a totally different process, as many of you know, from getting the PEng. And I'm a bridge inspector primarily, so when people ask me what I do, I say I travel all over, I put on rock climbing gear, and I climb around bridges, and I write up a report about how they're falling apart, and then a lot of times the client just ignores me. So that is, and that is the hardest part, because we have a legal obligation. The safety of the public's #1. So how do we actually make sure they're doing those repairs? And that's probably the hardest thing I deal with. It's pretty easy to see a crack and measure the size of it. It starts to become very difficult to talk with the lawyers and talk with the politicians and talk to people and say, you have to fix this. And then they say, how much is this going to cost? Tell them how much it's going to cost, and they say, oh, there's an election coming up, can we do it too after the election? So those are the sorts of things where I rely on Matthias, and I rely on other more senior people, and sometimes it gets fairly complicated, because you really got to make sure safety of the public's #1, and people have different opinions, and then sometimes people go to other engineers to get other opinions, and sometimes people just want to pay for your stamp to say it's okay, and that's completely unethical and totally illegal, but there are engineers that do that. So that is the most difficult part of my job, is kind of the external politics that I deal with. Probably one of the easiest things, and this is the final slide here, is I also do layout of new potential trails or new roads. So you're probably familiar with the West Coast Trail on Vancouver Island, and this is public knowledge as of just a few months ago, so I can share this. There's a new trail plan between Tofino and Yakluit. So right now there's only a highway that connects the two. So you're going on the highway, and the ocean's to your left, and sometimes you're right at the ocean, and then other times there's a bit of a forest there, and the plan is to have basically a new West Coast Trail that snakes through there. So it was my job for 3 months to live in Yakluit, and every day I just go out with a machete and GPS, and I would lay out what I thought the new trail should be, and then I would plot it on my GPS. We'd go back to the office, we'd show it, and we'd overlay the various different environmentally sensitive areas, the various different First Nations areas, the various different areas that Tofino doesn't want us to touch, or does want us to touch. And we have this Venn diagram of complete impossibility, because it's impossible to find a way that works for everybody, but we would say, well, maybe shift it a little bit more here. So then I would go back out, and then of course I find the problem, and there's a cliff here, we can't do that, so we have to maybe build a bridge. So that was about a 4-year process. We now have the alignment completely figured out. We have the bridges all designed, and it should start construction in the fall. So hopefully within a couple of years, you'll be able to do the new West Coast Trail between Tofino and Yakluit. So here's a picture of that's quintessential us at work. This bridge doesn't exist anymore. We inspected it and said it's so bad you need to get rid of it. So and actually, kind of as an asterisk here, I'm not going to tell you where any of these bridges are. Every single bridge is going to remain anonymous. Obviously, some clients would love us to tell you about the projects that went well, and other clients don't want us to tell you about the projects that didn't go well. So you might think you know where this bridge is, but I work in 50 states and 10 provinces and 3 territories, so don't even try guessing. It is somewhere in North America, and you probably don't know where this is. But anyways, that's kind of the more challenging bridge that we look at. Before you get to this stage, you start at this stage. I really don't want to spend thousands of dollars on plane tickets and get somebody to fly all the way to New York only to find out they're afraid of heights. So I can tell you where this is. This is in Richmond. So these are all guys, we go down there, and this guy here, he couldn't go any higher than that. And that's fine. That's totally fine. Like now is the time for you to find out that you're afraid of heights. So we get them there. Everyone's, of course, all in the harnesses. We're all ready to go. And if you can get up to that ladder, then you go up to that ladder, and then actually at the end, you graduate when you walk across that beam. You'll never have to do that in the actual world, but if you could do that, fully strapped in, and you can walk across it, and you feel nice and comfortable, then I know you can climb a bridge. So when we take you out to site, here's day one. Again, you have to be very comfortable at the top of the ladder. What's he doing there? He's loosening some bolts. So we're going to loosen the bolts on the trapezoidal box girder, and then we're going to go inside, and then we're going to close the door, and we have a gas meter with us because it's confined space. We got to make sure we have the proper amount of oxygen with us, and we turn off our headlamps, and we make sure we have multiple flashlights with us, because when the one battery dies, you're not going to be able to find the other battery. And the reason why we turn off the lamps, we close our eyes, and we wait to adjust, and then we'll see little pinholes of light. Then we can see potentially where the holes are. And then of course we turn the light back on and we look for various different defects inside the box figure. Now the ultimate graduation of heights, and I like playing this one. Can anyone see where the inspectors are? Right? So we walk all the way along the suspension cable. Yeah, so you wouldn't be doing
I would not graduate.
Yeah, that's totally fine. So as we're walking along, we're looking for various different defects that we see. This is a bridge here. It looks a little scarier than it is. That the ladder I'm on is probably at like a 30-degree angle. It's not straight up and down. And some of them, probably the easiest one is this one here. Some bridges, and it's great, and I say this to all the bridge designers, please put catwalks and actual sidewalks underneath your bridges. That's lovely, because you can walk along this, and it's nice and easy to walk along. Of course, it costs way more money, and in the P3 world, people necessarily don't want to spend more money to help a bridge inspector 20 years from now. But it is really nice when you show up to a bridge, and it's basically just walking along a sidewalk. What they have underneath here, we call this the Spider-Man machine, and there's little winches on either side, and it goes down, and you tighten up, and then it pulls you over, and then it tightens up again, and it keeps pulling you over. So you can kind of Spider-Man your way around the entire bridge. So here we are inspecting some of the top cables here, and people normally notice the cables, they look down, and then that's a buffalo. So sometimes we come across interesting animals while we're inspecting. We come across a shrew, which is totally harmless, but we also come across this animal. It's specifically camouflaged. It's a rattlesnake. So, you pay attention to various different problems and hazards in the field, falling objects, falling from heights. I didn't have rattlesnake on my hazard assessment list until this happened. And so yes, we're not only looking up at the bridge, we also have to look down at our feet because there are rattlesnakes where we do inspections. The main mode of inspecting, we use this vehicle here. It's called a snooper truck. And snooper trucks are great because they usually only just take up one lane of traffic, and then you can go right underneath the bridge. You can do it under active traffic. Here, there was active trains moving. There's not a lot of envelope that they take up. So snooper trucks are great. There's only a very few of them in North America, so they are kind of hard to rent. So you have to rent them well in advance. So there's one of the snooper trucks we use. I only know of one snooper truck that has railway capability. So this is the one that we use when we're inspecting bridges in Manitoba. And here's a bridge. This is up north. Again, a bit of a different configuration. Some of them, like you can see, this one has a very small box. The advantages of that is you can get right into a tight little area, but the disadvantage is if you're going back and forth and looking at different parts of the pier, that becomes annoying because you have to keep moving the arm. So you kind of have to think ahead of what are the various different constraints and what are the things you're going to be looking for. So you show this one. This one here, this one's in Ottawa, so the Parliament Buildings is right over there, and you might recognize this bridge from Justin Trudeau has done a lot of his photogenic jogs across the bridge, so this is the iconic Alexandra Bridge. And for this, you can see the size of our platform there. We were tasked with doing a whole load evaluation and rehabilitation of the entire bridge. So if we're going to spend 30 minutes measuring absolutely everything, everywhere, and there's going to be a team of 6 of us down there, we can't be standing in a tiny little super truck. So this one has a huge platform. It's 25 feet long and it's 5 feet wide. So we had our whole team down there, and they shut off the vehicle, and it just sits there for hours while we're measuring everything up. So this is back that same one. So concrete related. While we're down there, I am measuring the cracks. So every year I spray paint. We go back to the same bridge, and I spray paint all of the cracks, and if you were to zoom out, you'd see that the cracks in this concrete perfectly match exactly where the cracks should be when you have 4 piers like this and 3 beams like this. It's not the greatest design. I would have 4 piers like that and 4 girders like that, so the the force transfer is direct, and because of that, we have all these diagonal cracks happening. So every year I spray paint it again, and then I take out just a little crack gauge, and we're graphing how the cracks are getting larger and larger, and then eventually if the cracks get too big, then we'll put a collar on the outside of the hole here. And then we use man lifts to get to various parts of bridges. Here's us, again, a little bit afraid of heights, so we rent a crane truck, and we go in a bucket to get up to the top of the suspension bridge. We also use boats to get to bridges, so we do lots of timber borehole testing. And if the water is nice and calm, I have a fly fishing tube. So sometimes while I'm at work, I'll be in all my proper PPE, and teenagers will just flow past me in their tubes. Exact same type of water situation. When the water is a little bit more rough, here we have a little inflatable raft that we were doing inspections in. When we have to get into low profile areas, here's a canoe. We were doing timber drill testing up in Manitoba on a bunch of railway bridges. And here's just a picture. This is inside the SkyTrain tunnel. We were doing an inspection down there. So this is basically right underneath downtown Vancouver. We've inspected all of the culverts on the Alaska Highway. So when you're driving, if you ever just suddenly notice a railing and then the railing goes away, if you stopped and looked out and under, there's probably a big, large culvert there. And if you're driving the Alaska Highway, you're probably driving in the summertime. These are usually either completely dry or just a little bit of water coming through them. But then they have a thing called freshet. So when all of the snow melts, these almost get completely filled. So we have to make sure that they are not plugging up, because obviously you could sever the one line that goes up to northern Canada. So it's very important they get inspected every second year by either us or another engineering company, and then on the odd years they get inspected by Public Works as well. And then also more culverts that we've looked at. I've crawled through every culvert in North Vancouver and West Vancouver, and this one is the outlet. The inlet is in Francis Aquilini's house, the owner of the Canucks. So I went into the outlet, I walked through it, and when I got to the other side, I popped up into his giant compound, and his security guy came over, and he was just blown away, like, this is the best security in Vancouver, how on earth did you get in here? And I said, well, I'm working for the city, and we just crawled through the pipe. So they put a gate on it the next day, because it's a pretty glaring security hole, which is fine. Like, they had to clear it with us because there's a certain spacing of the bars, because you don't want that to plug up, and that would flood his property. Another thing, that there's at least 6 culverts in West Vancouver where people have used the culvert as a architectural feature of their house. So the culvert goes right through their property, and as I would be going through the culvert, I would see it's getting lighter, but we haven't made our way to the end of the culvert. They created a glass-topped culvert. So I would stand up and I would look into their living room. So they have the grand piano and everything. I'd be right there in their living room, and like it's all glass, I couldn't get in. But you can imagine the look on their faces when suddenly, like, hello. This is the most, I probably shouldn't use the word dangerous, but the most toxic work environment I've worked in. This is in the Tech chemical plant in Trail, BC. And in order to go in there, you have to do a day and a half of safety orientation, because what the plant does there is they bring in raw materials on trains, they do things with them, and then they bring off bars of the stuff. And what is the stuff? It's gold, it's silver, it's cadmium, which is in batteries, and it's a whole bunch of other toxic chemicals that in the process of smeltering them totally destroys the steel on the bridge, that the bridge goes right through the plant. So at the end of each day, I throw away every single thing that I'm wearing. It's just completely destroyed and eaten through, and we build that into our price because obviously we have to do new coveralls every single day. And as we're inspecting the bridge, they don't stop operation because it's gold. They can't, they would lose millions of dollars. So we'll be inspecting the bridge, and all this crap will just fall right down. And we're wearing like full gas mask and everything while we're pulling away the whatever it is, the effluent that we're looking at, and then we're measuring the bridge. So this is a very, very toxic environment we work in. The worst type of bridge that sees saltwater corrosion or other, it's got nothing on liquefied cadmium. That's horrible, horrible for bridges. So we go there on a regular basis, and we're constantly chasing the 8 ball of trying to fix the bridge. So that's a client that is always fixing their stuff constantly, because we say this is about to collapse because you just poured a bunch of molten gold on it, so you have to totally fix it right now, and they fix stuff instantly because they obviously have a fair bit of money. I helicopter to bridges as well. We helicopter to bridges. We do a kind of a cost-benefit analysis. If there's a hiking bridge that's owned by either BC Parks or Parks Canada, and if it's more than 30 kilometers away from a parking lot, we'll hike to it. We'll helicopter to it, because that's just more cost-effective. But if it's within 30 kilometers, we hike to it. So the West Coast Trail, I do that every year, and the Wanda Fuca Trail, the North Coast Trail. We even got Matthias out there. They had a situation where a bridge was basically collapsing, and they wanted some various spitball ideas for how we could fix it. So we hiked out to it and sussed out the whole area. And then Matthias and people from BC Parks, they flew out, and we said, maybe we put a bridge here, maybe we do this, maybe we do that. And we basically came up with kind of a conceptual ideas of how to do the new crossing. And what was their new crossing? What did they decide?
They just cut a tree and put planks on it.
Yeah, so they just cut a tree, fell over, and they said, that's the new bridge. So, but they paid us for the fancy suspension bridge that Matthias designed, so it was There's our Monday staff meeting. So when you're working in the bush, you have to make sure you bring everything, because you can't just go somewhere and get it. Extra batteries, extra cameras, extra everything. We have to be fully prepared for all this sort of stuff. We use drones to inspect bridges. Here we are. This is in the Port of Vancouver. The port does not want to shut down anything for a man lift, or they don't want to shut down the railway tracks, but with a drone, you can get right up there, you can look right in the bearing. This is another job. I can mention the client because this project went well. So this is in the port. Again, there's no way we could get that photo. If I zoomed out, we're right over top of active trains. You can't even get a man in there. And we looked at the midway joint here, and the drawings didn't make any sense until we started to see this joint. And this was a job that actually I think Malcolm was working on. And as we zoomed in, because we have a good 4K camera, it was a lot more evident of where things were breaking, and it totally made sense to the designers about how we were going to fix this. And I think we ended up putting in a link slab. So I don't look at my job as a bridge designer. I look at my job as a bridge inspector. I'm taking the photos, I'm giving them to Matthias, I'm giving them to the designers. They sometimes say, go back, take more photos. But to them, they were super happy with this photo, and I said, great, I'm a glorified photographer. So if you guys are happy with the photos I took, I'm happy. This was a job down in Delta, where basically this retaining wall was falling into the stairway. And from a constructability, I put this in for a constructability point of view. How do you drill in? How do you get your drill rig in here when the sidewalk is only a few feet wide and it's all on a big angle? And I mean, I kind of hate to give away secrets to our competitors, but it's okay. I'm okay with doing that. Basically, we did kind of an Egyptian style. Take a bunch of these were blocks of styrofoam, and styrofoam only weighs a few pounds. And from that, we could just put it on the various different stairs and create a flat platform. And we got our full drill rig perfectly right in there in order to drill in all of our anchors. Put in the rebar, and then the final product looked like this. And the homeowner complained that we hit his fence at one point, so we gave him a brand new fence. So this is the final one I think I'm going to do on the PowerPoint, and I'm going to show you some videos that are a lot more concrete related. This is a bridge on the Alaska Highway, which we worked with Unsu on this, and I'm happy to show these photos because this went really well, and it's going to construction right now. There's 3 bridges like this, and they all have the same design detail where, how do I explain this? The bearings, this is the bearing, so let's go back to the bridge, right? Here's the bearing, and this is the end post that comes down, and the bearing, okay? So here's the I-beam, and the bearing is pinching the inside of the web. So as the bridge is moving back and forth, it's basically just ripping the web right out of the I-beam. So I'll show that on a different angle here. Right, you can understand, they didn't fix it to the flanges, they fixed it to the web. And when I came in and I showed this to the client, I actually took a piece of paper and I got them to pinch the middle, and it just rips. So obviously, you're gonna have a crack right there. So on the next photo here, that's what it looks like, but then you spray on some stuff called dye penetrant. So you spray on this primer, and it seeps into the crack, and then you spray on something called the developer. Now, if it's just a surface crack, everything goes white. But if there's an actual deeper crack, it starts to leach out. You can see the crack here. And we tracked those cracks for a number of years, and we saw that they were continuing to develop more and more and more, and eventually it'll just completely rip the flange right out, and then the bridge will fall down 2 feet. Won't be a catastrophic collapse of the whole bridge, but it will certainly shut the Alaska Highway down if you suddenly have a 2-foot drop on your bridge. So they're there. The bearings arrived yesterday, so we're fixing it starting tomorrow. We spent about the last year doing various different designs. We had constraints like you can't shut it down to traffic, you can't restrict any of the load on the bridge, no load posting of anything, and you can't restrict any of the width of the bridge, and you have to build it all over the winter on the Alaska Highway in -30. Those were the constrictions. Oh, and you have to spend all your budget by like March 31st. So my boss was happy about that part, but no one else was happy about all the other constraints. So those were some of the things that I wanted to start with. I'm going to show you some video here of well. We're going to get a little bit more concrete related. Okay, so this is the first thing on the actual agenda where it says deterioration of concrete in a marine environment. So I start with this video. I'll play it a couple times. All these videos are quick videos. This kind of shows you what good looks like. So there's a good idea that if you want to know what bad looks like, you need to see good a few times. So I'm going to show it once. Okay, show it again. You know, obviously you can see where the formwork was. You can see the water lines. There's a couple cracks here and there. Okay, so that is okay. So now let's see the very next, and this is only a few feet away. This is the exact same structure, only just a few bays away. It was built by a different contractor. So really a lot of it just comes down to poor workmanship. The first thing I noticed, they left a lot of their formwork like right on site. They didn't even clean up their actual work. And then all of the joints are also leaking, and all of the joints here are leaking as well. And this was the first bay. We had about 40 bays to look at. And so this is the end beam, and you can see there's just a lot of rust staining coming down at all the end beams. So if you see a problem, there's a pretty good chance that there's a much deeper problem buried somewhere inside that structure. So this started to get me a little bit concerned. Okay, this is just the first one. Like, how much worse does this get? So I'll show you what happened in this next one. So we went to the next bay. Kind of hard to see in the video, but the corrosion here, this is supposed to be a flat face, but it's eaten it away by about 1 inch. And we're starting to actually expose some of the rebar here as well. So again, my job is to find the problems. I'm not afraid of heights, I'm not afraid of crawling through bird proof. I mean, my job is to find the problem, measure the problem, hand it off to Matthias and his team, and then they tell us how bad this necessarily is. So I do all the measurements here, and then we have load graders and various different designers who can then say, well, you know, the factor of safety, it was way over designed, so I think we're okay. Sometimes that doesn't happen. Sometimes they say it was designed right at the line, and and you've had some deterioration, so we need to potentially shut this structure down. So this obviously was raising quite a lot of alarm bells for me. And another thing, you can notice here how bad it is, and then you look into the other bay, and it's not as bad. So what's the root cause here? Well, there's a joint in the structure here. There's a joint here, and there's no joint here. And a lot of times, Matthias introduces me as Grant's the guy who teaches me what not to do, which is kind of seen as an insult, but that's not what he means as an insult. He means I see what designers shouldn't be doing. So I go back to the office and I say, guys, figure out your joints. You need to do joints properly because water absolutely kills concrete. It's so terrible for concrete. You need to get the designers on board to make sure we're flushing water away from the structure. There's no joint here, and that looks fine. There's some formwork that I left in. And there's a joint here, which hasn't been dealt with properly. And you can see, this is the external deterioration. We don't know what's going on inside where that water might be pooling up. So as I got to the end of the bend here, and I had 60 or 70 or so to go through, and I was starting to get a little complacent because they all started to look the same. And that's a problem with inspectors. We need to make sure we do a thorough job. Don't get tired at the end of the day. I started to notice something right here, and I thought, you know what, I need to get out of my boat here. So I got out, and you know, we always wear gum boots so we can get our feet dirty, feet wet. So here I am standing on the shore, and this is the main load carrying beam of the bridge of the crane above us. And these rebars are supposed to be straight, and they're supposed to be in concrete. So we looked at the design drawings and we counted, and every single one, like that's the best one you got right there. Obviously, even that one's completely debonded, and they're not supposed to be bent like that. So you look right in there, and you can see, I mean, obviously shear is highest right at the end, and this is shear popping it right out, bending all the rebars right up. So, okay, how's the other side looking? Because when there's pop on one side, how's the other side? Other side looks okay, but if the problem's happening there, the problem might be happening on the other side as well. Pause it right, yeah, right about there. So this was a situation where we shut it down. We told the client, you cannot safely operate on this. You know, we've done our calculations where in like new condition, you probably shouldn't be operating these larger capacity cranes. So that is an interesting battle there, but as far as we know, they've shut it down. As far as we know. So the root of the problem here, what's all the white stuff on the ground? It's salt. Salt is terrible for concrete. And here's the joint, or lack thereof, of a joint. So again, we say to designers, when you're designing a joint, actually design a joint, because, go back again, because the force is going to find a way. It's somehow going to find a way. It's broken the asphalt, the water's still going through, and it's still eating away at the bridge, at the structure. And where properly designed by the other engineers that built the other dock is right here. And we don't see that same problem. So the thing I really want to stress to all designers is, you know, please design your joints and your water away from the bridge. Make sure you somehow are able to get it away, because when you have pooling water, especially pooling water that's filled with salt, or salt water, or water that freezes and it cracks and freeze thaw, we always want to make sure that we can get water away from bridges. It's the worst thing that I've seen, except for liquefied cadmium. But the thing that we normally deal with, water is terrible for bridges. Perfect, right on time here. So this is the same bridge that we saw before. Let's scroll through some of the photos just so you're familiar with the bridge. It was a truss bridge up on the Alaska Highway. And so here's a deck, a graded deck. So where does the water go? Where does the salt go? Where does the snow go? It goes right through the deck. And what happens is to the abutments, right? I mean, the concrete has spalled away about 8 inches, and we're down to the 3rd layer of rebar. So this whole thing just gets completely covered in gravel. The gravel holds in all the moisture. Again, I always say to people that are doing maintenance on a bridge, clear the gravel away from a bridge because the gravel holds all the moisture. The gravel holds all of the salt, it holds all the sand, and it completely eats right away. Happy to say this has been completely fixed. We were fixing it just a couple weeks ago, and this is the same bridge where we were fixing and swapping out the bearings. Here's a joint repair. I want to show you here. This one I can tell you the client was the Port of Vancouver. They were quite happy with how this one went. We're probably all familiar with concrete D-lamp. A lesson learned here: make sure you don't just jackhammer out the area of D-lamp. Go quite a bit beyond it. We did this job back in 2014, and we have to do it again because we didn't go quite out far enough. So that is kind of on us. We needed to go a little bit more. But also D-lamp patches a lot of times don't work so well. And they don't necessarily have the same life expectancy of fresh concrete. The job here wasn't so much the D-lamp patches, it was the joints. So the joints were leaking, they were deteriorating the girders underneath. So we jackhammered out, we pulled out the old expansion joint. We cleaned it all out. We removed everything from the joint. Some of the old joints we were breaking out. And here's kind of the new joint that we were putting in. So it's a sinusoidal bar, and we were going to put in a product that I highly recommend. It's called Waldie. So there's an example of the old joint, which was all destroyed. Some other site photos here. We started forming up where we were going to put in the new joint. Again, here's an issue where the concrete was starting to deteriorate, so go back a number of inches past the actual point of deterioration, clean it all out. The rebar that we were chipping away the concrete, and the rebar was not normally deformed, it was just smooth bar. So we had to put in new rebar. There's some more rebar exposed. It started to form up in the middle. Some more forms on it, and then there we have put in some of the new rebar. We start putting in patching material down on the bottom. Heating and hoarding, protective tents. It's always great to work when it's not raining, to work when you don't have the wind blowing against you. It's also a lot nicer for the contractors. They stay nice and warm. So a happy contractor is a productive contractor. So I really highly recommend even putting in the specs saying make sure you put a little tent around the areas that you're fixing. And then as we got towards the end here, we started to pour. There's the sinusoidal anchors, the tents. There it is, fully formed up with the bars. I really recommend this product, Watson Bowman Acme, Wagyu Creek 2. Really good product to use. It's kind of a multi-step. You mix it in with these different pellets. And then it pours basically, and the only bad thing about it is the bridge was on an angle, and the Wagyu Creek keeps kind of slowly falling down, so we had to get guys with trowels every couple minutes to kind of push it back up, but that's okay. I mean, if that's all it takes, there they are, yeah. It's a great product. It sets up in a couple hours. That's kind of what the finished joint looks like. And I'll snap to the photos here. I believe this is the final product. Yeah. So it creates a nice look. It almost has an asphalt type look. Again, we wanted to think about drainage, think about relief here, think about how we're getting the water away from the joint. And these are the patches that we finished. And these are also some patches that we did to the girder underneath. We hilted in some anchor bolts to then put on these patches so they had something to adhere to. A lot of times I see patches that don't have anchors like this, and so when you put on your patch just snaps right off. I think we have just 2 more minutes here, so I want to think about what the best one is to show you. I want to show you this one. Well, I'm going to show you this one. Yeah, so these, I have 2 folders here, fixed and original. So original. Yeah, this is a train bridge. And at first glance, looks okay. Bit of a hump on the approach there. Again, nothing's really jumping out to me. Okay, concrete showing its age. I mean, it's 1936. Okay, that looks pretty rusty. Okay. Start to see cracks in the steel. I mean, if you see one crack one place, you're going to see one crack some other place as well. So we're losing all of the heads of our rivets here. And you see we even have a hole in the web. So if we have a hole in the web, that doesn't mean that the web right here is full thickness. Obviously, it's knife edged right down to a hole. Okay, we see more knife edging. It's really hard to measure with calipers the thickness of that, so I spend a lot of time up there with a wire brush. Okay, more holes in the web. I'm starting to get a little bit more concerned. Okay, now we have holes and perforations right along the web. Getting worse. More holes. Right along, all the rivet heads are gone. This is the main girder, and you can see it's perforated right along here. More holes, more holes. That web doesn't have much left. Neither does that one. This is a hole. Now I'll show you at a different angle. That's the same place. So this is the main beam. There's no redundancy in this system. If that goes, the bridge falls down. There's no redundancy. And if you do your calculations and you do your section modulus, you've got a top flange, a bottom flange, and then you've got nothing. So from a math point of view, this doesn't even stand up. Obviously it is still standing up. So basically the load finds a way somehow, but this bridge should be shut down. So we did. We shut this bridge down. We said you cannot run via rail passenger trains at 70 miles an hour, which is what they were trying to do with that. So the emergency got some fixes going, and I will show you the fixes. Okay, so you can see we replaced all the floor beams, or at least the worst floor beams. I mean, some of them might have been rusty, but not in horrible shape. You can see some of the floor beams over here were replaced. More floor beams, more floor beams. The web all in here. You can see the brand new bolts. We looked at every single stringer and which ones should be fixed, which ones shouldn't be fixed. We replaced the bearings. And that kind of overall shows what we did. Lots of gusset plate fixes, lots of cross bracing replacements, and that worst picture that I showed you was right here. So we totally ripped out everything. We did it over the course of a weekend, and didn't have to. We shut down the train traffic, but we didn't have to shut down the highway traffic. We had single lane alternating, and we were able to get via rail going the next Monday. Basically. There's still problems on the bridge, so I still go back there on a regular basis, but it's certainly a lot better. So that's my 45 minutes. I don't like it when presenters go over their time. Does anyone have any questions?
So
Yes,
what's
Pat.
the message there? Build with concrete?
The main message is get water away from your bridge. That's the main. So you see the concrete problems, and then you see the steel problems are really terrible as well. So I always really try to stress water is absolutely terrible. And I give these presentations to all our designers, and you really never want to have water near your bridge. sir.
So when you're hiring people based on their fear of heights, do you find that people either have it or don't, or can you kind of like build up your tolerance to that?
I normally ask people if they ski. And so if someone says they do delirium dive or Spanky's ladder, or then kind of get that, yeah, you're gonna be okay. Yeah, I mean, even if you're afraid of heights, there's less going up to heights jobs that we do. You know, certainly you can inspect a bridge and not necessarily have to be at those crazy heights.
Yeah.
But it is good to kind of figure that out a little bit before you get hired. But even if you can't be an inspector, you know, people work with Matthias, people work with lots of other people in the group. So we like to move people around to various different divisions. Yeah. So still apply. Yes, Matt.
So do you use like a mountain climbing safety sort of protocols, or do you use like work safes? Because there's kind of a little difference.
Yeah.
Post and chair,
Right.
work safe kind of thing versus mountain climbing.
So what we do is we have the work safe harness that we use, and the typical one that you see on a construction site we don't use. Those cost about $60. We buy like the $400 extremely comfortable harnesses because we're in them all day long. And we apply work safe rules BC, and then what we'll do on individual sites, we'll say, what is your safety policy? And if theirs is higher, we always go to the absolute highest one. Some clients have no safety policy whatsoever, so then we go with the work safe BC policy. You know, we're always tied off. I have a rule that I do all my climbing with my feet. So lots of people, you know, they're climbing with their hands and they're doing all these crazy moves. I don't do any sort of crazy thing like that. I'm always just walking up a ridge, and I happen to be clicked on, just from a safety point of view. Yes, sir.
Are you modifying your drones at all to take actual measurements?
What we do with the drones is we take photos, and then from the photos we're able to stitch them together to create 3D models, but it's all still just on the regular camera. But there are bigger drones where we can use bigger types cameras. There are guys in Parsons USA that do that, but no one in Canada yet does that. Yes, sir.
Yeah. Do you inspect underwater for scour and that sort of?
Good question. So we first start by inspecting, looking into the water, and if you see a hydraulic jump happening, there's a good chance that there's scour there happening. So I'm not personally a certified diver, but we have 2 diving companies that we work with, and so if we identify that as being a problem, then we get them to go to site. And what they basically do is they kind of, because the water is going so fast, they hook on the land and they repel themselves as the water is rushing past them, and they map out where the various different scour is. So I think of all the bridges we look at, we probably do that to about a dozen of them. A lot of the bridges, the water is so slow moving and it's only a foot deep. I myself can walk in, so I have chest waders and hip waders, so I'll go into water up to here and I'll use a stick to kind of poke around for scour. But for some of those bigger bridges, we hire up to a diving company.
Have you come across any bridge where they use impressed current DC corrosion protection systems?
That's the Arthur Lang Bridge has that, correct, Vincent? Yeah, the Arthur Lang Bridge has that. Yes.
The deterioration mechanisms for steel are relatively straightforward in comparison to concrete. When you're looking and going through your inspection, how deep do you get into what sort of deterioration is actually going on with concrete?
Yeah, so it's a good question. I like to always be just kind of the first line of defense of finding the problem. And if it's very obvious to me, like I do chain drag, I do deck delamination, that sort of stuff. But if it's anything like chloride content or anything more deeper than that, then we hire out to metro testing or to other people that do those levels of testing. So I personally don't do that. We don't have anyone else that does that. Basically, it's our job to get to site and ring the alarm bell of shut it down, or say we recommend to do these further types of tests. Yes, sir.
Have you seen anything over the years in the way, or any change in the way bridges are constructed out of concrete that lend themselves to fail sooner or later?
I mean, definitely the detailing of water is getting better. I'll say different areas have different types of bridges. I probably shouldn't say the bad ones, but I can say the good ones. Alberta really does a really good job job, Alberta standards, their bridges are very well built, from what I've seen. Yes, sir.
Have you ever used strain gauges to assess the tensile forces in the bars where you see a big problem and you say, well, you have to shut it down, or really do some forensic assessment of it?
I don't think we have done that. Did we do that on, was that one? We worked on it.
Coal mine bridge?
Yeah. No, we didn't do strain gauge on that,
We just
no.
measured the crack and how the cracks propagated.
Yeah.
When you put strain gauges on, you be careful because you don't get the initial stress. You get only the additional strain, and then you can calculate back what will be the additional stress. As long as the rebar, and let's think about rebar. As long as the rebar is not yielding, I would say you are fine, because when the bridge is properly designed, you get well distributed cracks. When the rebar starts yielding, then it builds basically one big crack, and it doesn't do anything in terms of crack distribution anymore, because it's just building that kind of hinge, and then it continues there where the crack built first. And then you see what's going on. So when you find crack with in the order of 0.15 to 0.2, I think everything should be fine when the bridge is properly designed. When it goes into 0.5 or a millimeter crack, you can assume that the rebar has yield, or you have no rebar at that point at all. So then you build only one crack and you get no distribution anymore.
So I'm a big believer in, you see the problem, let's get it all out, let's fix it. A lot of times clients are a big believer in, no, let's throw more money at continuously monitoring it. Personally, I just like to fix it. So I definitely see the value in strain gauges, but we just normally don't recommend them. Yes, sir.
Could you please comment on epoxy coated rebar versus stainless steel versus black steel? Your experience?
In my experience, the stainless steel rebar is not old enough being used that I've seen that in a lot of the deteriorating bridges. So I mostly inspect bridges that were built in the 1800s and the 1900s, like early 1900s. So I see a lot of not even normally, just straight bar. So one would assume that stainless steel is better, and then followed by epoxy and followed by black bar, but I don't think that would be perfectly known until about 100 years from now. But yeah, I mean, I think we would probably all agree that that would be the order in which they go. I've never seen stainless steel rebar in concrete corroded. I've never seen any problems with it ever, but that might have something to do with the fact that it's not as popularly used.
Maybe I can say something about black steel, epoxy coated steel, galvanized steel, and stainless steel. So first of all, the stainless steel has a higher strength, and many suppliers try to sell that as an advantage, that you need less rebar. It is not an advantage. And why? Because the most important factor on rebar is crack control. That is what governs the amount of rebar. And in crack control, you want to keep your rebar stresses around 200 MPa under service load conditions. So when you're not getting to the high yield, that high yield doesn't help you. So that's the first thing. Of course, stainless steel is good, because when you have a crack and you get salt in it, it doesn't trigger that kind of corrosion mechanism that you find on black steel. Galvanized steel is definitely better than black steel, because the zinc sacrifice. But when the zinc is gone, it's like black steel. Epoxy coated steel has the problem that it reduces the bond. The bond is very, very important for crack control. And then they had a lot of issues with the epoxy broken, and then it's not better than black steel. So that's actually worse. You get less bonding, and you get basically black steel.
I noticed that a lot when I worked in construction. They'd have epoxy coated bar that we were all just smashing and breaking off the epoxy.
So when you have black steel, you know the problem, and you make sure you have a good cover, and that is important. And that you have basically, as Grant says, the critical joints well addressed, water well addressed, because you need to see it this way. The deck of your bridge is your roof of your structure. When you have a hole in the roof of your house, you better fix it, because when the water comes in, your structure gets compromised. The same applies with concrete or steel when you have a bridge, just that it doesn't go as fast as with timber. So please get in early on when you have a leaking joint and fix it.
That's a good analogy with the roof. We have roofs with gutters, with drains that go down to the ground. Why we're designing bridges with no gutters, with drains that go down to the ground is beyond me. So really well impressed upon the drainage. Any other questions? I'll end with one fun one here. So this is impact damage. This is in Chilliwack, and a truck drove right into the barrier here. And the truck was carrying grain. That's exactly what it was designed for, exactly that. Yeah, so it did exactly what it was supposed to do. The truck was carrying grain. How do you find a grain truck driver when he hits something? Trail of breadcrumbs. We followed him for 2 kilometers, and he was in the middle of a farmer's field saying, "Wasn't me, man, totally wasn't me." So that's what it looked like. We did a quick design, and then the final version, and I think within 24 hours, that was the fixed version. And we even cleaned up most of the grain. Thank you very much.
So thank you, I really, really enjoyed that. That was a very well done presentation, so thank you very much. Just a couple announcements before we go.